Welcome to the Signal Drop, where we discuss all things telecoms. Whether you're a newbie, a nerd, or anything in between, this podcast is for you.
So over the course of this podcast, you'll hear from the Mpirical trainers imparting their knowledge, you'll hear from the Mpirical team, and from time to time, we'll even bring in the odd guest speaker. Well, hello everyone, and welcome to podcast number 3. It's quite a serious podcast this time around because it's one of our technical Q&A sessions that we're going to run on a relatively regular basis. With me in the studio today is Kev and Tom, who are trainers.
Hello everyone.
And we've got a very special guest this time round, Morgan. Well, actually, Morgan's been in every podcast so far. But,
are you implying that I'm not that special?
No,
then?
you are.
Right,
Okay. So to facilitate this, Morgan's going to ask a series of questions. These questions are all largely surrounding 5G, and the trainers are just going to give their answers in a descriptive way as possible. We're not in a classroom with a whiteboard, so we do have limitations there. But over to you, Morgan.
Yes, hello. These questions that I have in front of me come from our on-demand training in our awesome learning zone. In case you haven't checked it out yet, please feel free to go and take a free trial. Within each of our training modules, we have this feature called Ask the Trainer. So our students can click a button, and if they have any question about their training, they can fire it off to a trainer who will then respond to it. Some of these questions are ones that have been produced over the course of the last few weeks, and we thought they were interesting enough to share with you. The first question, and I'm very excited because I get to drill all the trainers, and I've got Tom and Kev over here looking particularly concerned that I'm
Not concerned at all, just ready to impart our wisdom.
That I'm going to throw them a curveball, so I do hold the power. First one. Can a 5G PDU session have multiple bearers, including both default and dedicated?
So I guess that's where I come in then. So hello everyone, Kevin here. In terms of the question itself, the terms default and dedicated bearers really, I mean, they are 4G terminology. In 5G, we don't have default and dedicated bearers. What we have instead are QoS flows, quality of service flows. And I think the key point to make here is in a similar way to 4G, where you could have multiple dedicated bearers. In 5G, you can have multiple QoS flows within a single PDU session.
What's a PDU session?
Protocol Data Unit Session. So this is our data session in 5G. So equivalent to PDN session in 4G.
PDN connections.
PDN connections.
Yeah, and you know, in 4G and in 5G, we're still in quite early days, I guess. So we're not seeing massive amounts of examples. You know, for a typical user, there's not huge numbers of QoS flows within PDU sessions. We don't have lots and lots of PDU sessions at the moment, but I'm sure things will change as we move forward.
Okay. I don't actually have any questions. That was quite a comprehensive one. So I guess we'll move on to the next question then.
Sure. We're enjoying this.
Okay. I think we need buzzers. That would just liven things up a bit.
I just wouldn't press it.
Yeah, mine would get dusty.
Right. How are the 5G 5QIs mapped into the transport network? Usually in 4G, the PGW is mapping the QCI into DSCP or DiffServ, but in 5G, what is the mapping, especially for delay critical 5QI?
I'll take this one, Morgan, and I'll decipher some of the terminology that you use.
I don't think that we could have had any more acronyms.
Yeah, so 5QI, it's a 5G QoS indicator. So when you get connected to a data network, the way that 5G can differentiate between different levels of quality of service is by giving these QoS flows that Kev just mentioned a 5QI value. And something similar is used in 4G. It's almost identical in 4G. It's called a QCI value, a QoS class identifier. So I guess this question's about, well, okay, if you've got these 5QIs or indeed QCIs, and you know you need to map them to the transport network. And what we're talking about here is if we have a packet of data that arrives at either a P gateway in 4G or a UPF in 5G, and we want to send that packet of data down to a base station, it will be sent on a transport network. So if we've got all these different levels of quality of service in operation in the network, it's really important. And these levels of quality of service, by the way, are really relative to the air interface and scheduling. But it's really important that when we do transport the different kinds of data across the transport network also gives that data the appropriate level of data forwarding. So in a transport network, we use diffserv, differentiated services. And what you've got to do, and this is going to be the job of the P gateway or the UPF in the downlink or the base station in the uplink, you've got to map the quality of service of the QoS flow to the correct value in the IP packet, which will be used in the transport network. So diffserv, so each IP packet gets what's called a differentiated services code point, a DSCP, in its header. And then when the routers, I say router for your sake, Morgan.
Thank you. I can understand it now.
In the UK, we say routers, but when that router sees the DSCP field, it sees a certain value and it knows how to handle traffic at the transport layer. And really, talking about how is that mapping achieved and how it's achieved for delay critical 5QI, which is a new QoS in 5G. It's dependent on how diffserv is set up in the network. So the network operator will need to set up diffserv in the transport network to reflect the different levels of quality of service that are being given to the 5G overlay network. So we talk about things like expedited forwarding, best effort, and assured forwarding classes. So it needs to be set up and mapped appropriately. And that's where we are really. It's all a case of provisioning before data starts to flow. And you've also got to factor in network slicing as well, because network slicing is going to impact resource usage in the transport network. Sorry, that was a really long answer, wasn't it?
No, it was good. I think you answered this question already. So does that mean that each operator can choose what value to assign to the QI?
Yes, kind of, but you'll find that, if you're setting up a transport network to carry voice packets, then everyone will use what's called expedited forwarding in diffserv. But there's quite a lot of what are called assured forwarding classes, and there is a degree of flexibility that operators can use. The only problem is if you've got operators doing different things in the transport network, when you start sending traffic between different operators, then you don't want to have inconsistency. So, ideally we need to get some rigid mappings, and there were some actually. The GSMA put forward some mappings between QCI values to DSCPs. There is a document out there, but I've not seen something similar in 5G. I'm sure it's out there, but...
Thanks for that, Gavin. Any more comments on that? I think it was fairly comprehensive.
It was very comprehensive. I want to stretch it out even longer.
I'm so impressed by the acronym knowledge that you've got just sat in your head there, all of you. On to the next question then.
This has got to be Tom's turn.
I know Tom's just sat there ready to go. In non-standalone 5G, Tom, during the initial attach procedure, who establishes the bearers for IMS and internet data forwarding through the E node B or NG node B?
I thought if I stayed quiet, I wouldn't be able to answer any questions. So
it's an ENGNB. Yeah, it's a 5G base station used in a non-standalone 5G.
I was close. I thought that I was there, but Tom understood it anyway.
Yeah, of course. Yeah, definitely. So really, this question is actually relating to the flow of data within a non-standalone configuration. So we need to remember it's talking about the initial attach procedure, and that's going to be device triggered. So with the IP multimedia subsystem, establishing that bearer, that's going to be through the E node B. So that'll be the master cell group bearer. That'll be established there. But when we're talking about the flow of data from the internet or from a data network, that's going to be through the secondary cell group split bearer. So that'll be passed through the ENG node B. And some of that data will flow then onwards to the device over the air interface, but some of that data will be passed upwards towards the E node B and passed down through the device using 4G as well. So we'll be communicating with the device in 4G and 5G.
So what, I mean, you use quite a lot of quite specific terminology related to dual connectivity there. So like an MCG bearer or an SCG split bearer, just to explain this to you, Morgan, in less technical terms, I guess.
Kev wants to know too. He's over there biting his nails in anticipation.
When you're on non-standalone 5G, basically, internet data will use the 5G base station and the 4G base station at the same time, and it's called dual connectivity. And your phone will be getting, data exchange from two different base stations. But for IMS traffic, which is voice traffic, that just stays on the 4G element of non-standalone 5G. And that's related to, in early 5G deployments, we don't have ubiquitous 5G coverage. So we just make sure everything stays on 4G.
So if my device is receiving from two different base stations, how does it know which one to accept different data from or exchange?
So it's all controlled by the... sorry, I took over your question.
It's fine. You've got more knowledge on this than me, definitely.
It's all under the control of the 4G base station. It's called a master E node B. So the 4G base station, even though we talk about standalone 5G, it's actually the 4G base station that's got all the control of who does what and when, kind of thing.
It is starting to click a bit. I remember you talking about standalone and
in podcast one, yeah.
In podcast one, of course. And then Tom, you mentioned a term, and I can't remember the whole thing. Multimedia, was it sub-bearer?
IP multimedia subsystem.
Subsystem, that's what
So that's for voice.
Oh, okay.
What Gav explained previously.
Just a call control network.
Okay, well, apparently it's not anything too cool to talk about it. I thought it sounded like
it's
a really
been around a long time.
awesome thing. Okay. Well, thank you for that, Tom and Gavin. The next question, who wants to take it? If you call it out now, I'll go easy on you. No? Okay.
I'll do that.
Okay, thanks, Gavin.
But I'm not doing the next one.
The question is, and this, remember, comes from a student who's asked on the Ask the Trainer feature in our training. I see that TAIs are used in 5G. Are they any different to 4G?
TAI lists, tracking area identity lists. Well, TAIs are used in 4G and 5G. They are the same, but I think this person was asking specifically about tracking area identity lists. So in 4G, these were introduced to reduce the number of tracking area updates that were taking place in the network. So essentially, a phone could be given a list of tracking area tracking area identities, and as long as the phone stayed within that list of tracking area identities, it didn't need to do a tracking area update. As soon as it leaves the tracking area identity list, it would obviously need to start doing updates. So as I said, the reason for this is it cuts down on the number of tracking area updates that would be seen in the LTE network. In reality, though, in LTE, because all operators use circuit switch fallback, tracking area identity lists cause problems because they increase the area, so to speak, and circuit switch fallback would kind of suffer in lots of different ways if tracking areas were bigger than location areas, and it's all related to call setup times and MSC positioning and things like that. In 5G, we've got exactly the same concept. We've got tracking area identity lists, and they're called registration areas, and we don't do tracking area updates in 5G. We just do registrations with a mobility update, but they are still available, and it's exactly the same concept in 5G. The only difference is, of course, in 5G, we don't have circuit switch fallback. So the potential limitation in usage in 4G for tracking area identity lists isn't as prevalent in 5G. So it's quite early days, of course, for standalone 5G. So time will tell whether or not or what volume they'll actually be used in. But to go back to the question, they're not really different. They're pretty much the same concept in 4G and 5G.
So the TAI, when we're talking about tracking, is that so the device has sort of a perimeter, a proximity that it can find a base station to connect to?
It's about tracking areas are really about understanding where the device is roughly when it's in an idle state. So your device can't have whatever radio it's using, 4G, 5G, whatever, it can't have it switched on all of the time because your battery will be drained. So your device gets sent down to like a dormant state, if you will. Okay. And the problem is the network will lose track of the device to a degree. So as long as the network knows roughly where you are, it doesn't need to page the entire network, which consists of tens, if not hundreds of thousands of base stations. It knows roughly where you are, and that rough area is called a tracking area. So it will just page the base stations in your tracking area.
Okay, thank you. Learned something new. Next question. I understand that 5G numerology... Now, again, this isn't me asking this question.
It's not you who understands.
I wish. I understand that 5G numerology means that you can change the subcarrier spacing for a radio channel. But why is this important?
So I guess that's one for me then. I think the point to make here is this relates to the scheduling of radio resources, and the term numerology, though it sounds quite complex, really refers to simply the flexibility that we have in 5G in terms of how we allocate these radio resources. So the point to make here is that, and how this relates to subcarrier spacing, is that as we increase the numerology, the slot duration itself reduces. And the benefit of this is that it gives us a higher opportunity to schedule data, and this can be particularly useful for use cases such as low latency, for example. Now, the trade-off here is that this does lead to a shortening of the cyclic prefix, and just to explain that in simpler terms, ultimately what it means is that we are more susceptible to multipath. So there is a trade-off in terms of, why don't we just, increase the numerology and provide everybody with really low latency. But ultimately, this is a balancing act in terms of how we schedule these radio resources. And we often find ourselves talking about this kind of idea of Tetris, if you will, in terms of how we kind of fit all of these different use cases, if you will, these different connectivity types together, and how we allocate the radio resources.
Yeah, it is just a big trade-off. You can't just use really high subcarrier spacing all the time, because it means really large channel sizes, and Kev just mentioned the cyclic prefix issue. So,
oh yes, that cyclic prefix issue
that
we all know about.
Where's Phil when you need him?
Kev, I know you mentioned about URLLC use cases. I know that 5G obviously enables this, but are there any particular applications or use cases that would require low latency versus all of the other 5G features that come with it?
Yeah, well, good question. Thanks for putting me on the spot.
No problem.
Yeah, I guess there are a number of use cases where low latency is not only important, but it's critical. So if you think about safety systems, for example, but even if we move to things such as real-time communication, so applications such as AR and VR, for example, will require low latency connectivity. And really anywhere where we have, a strong requirement for low latency, well, that's going to be significant.
I think in industry is quite, and the thing with industry is you can use a private 5G network in an industrial setting, so you've got much more control over which devices are allowed to use the network. You've got much more control over the way in which resources can be scheduled and configured.
Great, thanks for that. On to the next one. Are most real-world 5G networks of today deployed as cloud-based?
Oh, good question. I'm on safer ground here, I have to say. I think the point to make here initially is, when we look at the deployment of 5G globally, we're still only seeing probably around 50 standalone networks at the last count. And the point to make here is that when we talk about kind of all of the features of 5G, we talk about the cloud native approach. What we're talking about here is standalone networks. So I think the point to make here is no, not at this stage. There will be the majority of networks throughout the world will use some form of cloud service. There's no doubt about that. And in terms of standalone, what we're really seeing is a mixture of there are some networks that have deployed largely using public cloud infrastructure, but these are fairly few and far between. What we typically see is a more hybrid-based approach. So when we talk about cloud, there's a temptation here that we can fall into thinking of this kind of centralization of resources. But what we're talking about really is an architecture. And this can be both private and public. And indeed, if you think about most mobile operators, they've got significant amounts of in-house expertise. There'll be several other reasons as to why we might want to keep things on premises, if you will. But that's not to say that we wouldn't see this in a kind of private cloud configuration, if you will. But I think the majority of networks will employ a hybrid approach in terms of the cloud resources that they use. And really this makes sense because it gives you this kind of best of both worlds approach in that, yes, we can keep the things that we need on premises, and when we need to break out, when we need to use this idea of kind of multi-cloud or cloud bursting, if you will, and I prefer to leave that to Kate Bush, if I'm honest. When we see an increase in demand, we can then utilize public cloud resources, and that gives us the flexibility that we tend to see with cloud.
Just going back to the question, are they all deployed as cloud-based? Is it right to say that yes, they are largely cloud-based, but it's whether or not it's private, hybrid, or public, which is the real kind of...
Although I guess I have the issue with cloud-based. When we talk about cloud-native, I guess you would say that these standalone networks, yes, they are cloud-based. Other networks may integrate elements of the cloud, but there may be some degree of, of separate on-premises equipment that's used as well. But even in a private configuration, the likelihood is that we're still using that, a similar architecture to what we see in the public cloud. So we might see things such as OpenStack and OpenShift used, for example.
But even 4G uses... cloud applications these days as well, doesn't it? Yeah.
We see a mix of both, right? Where vendors are selling 4G/5G deployments as well.
Combined solutions. Yeah, it's very common.
And Tom, I think we touched on this last time, so forgive me if I am repeating questions, but it is really interesting how we are moving everything to the cloud. The fact that we are moving more into the cloud with our network architecture, does that create space for more vulnerabilities?
Definitely, it's the way that it's often described as there's more attack vectors. The more infrastructure that we're implementing and using, there's more attack vectors. The analogy I normally give for this is, in terms of vulnerabilities, if you're at home, the last thing you do at night is you lock all your doors, lock all your windows. Implementing more infrastructure is essentially having a larger house. So every time you're going to bed at night, you're locking more windows, you're locking more doors, and it only takes one of those doors or windows to be open for an attacker, or a thief in this case, if it's with your house, to actually exploit that vulnerability which exists. So as a defender of cloud environments or of 5G, you have a larger attack surface that you have to look after, whereas someone who's actually attacking the infrastructure, that just means you've got more opportunities to identify vulnerabilities.
I think another point to add there is that obviously with this move to cloud, we see a shift to using commodity hardware or commercial off-the-shelf hardware, which means that there's a greater degree of knowledge that exists out there in terms of potential vulnerabilities, in terms of how to attack these devices that we might not have seen before in more kind of closed proprietary telecoms hardware, for example.
A lot of organizations, especially within industries we were speaking about previously, the industrial application of 5G, they often used in things such as nuclear power plants, security through obscurity. So the systems are so complicated that people don't understand how they actually work, operate, and function. But as Kev said, as we're aligning to more traditional IT, that doesn't become the case anymore. So more people are also aware of the infrastructure which exists.
And of course, the connectivity to the internet is obviously
and
quite
that
significant
doesn't help
in terms
as well.
of that attack surface.
You use nuclear and obscurity is quite an interesting one because Stuxnet kind of killed that, didn't it?
What, the obscurity element?
Yeah.
Well, I guess so, yeah. We still obviously have, we have nuclear infrastructure in the UK, and a lot of that is running on very old operating systems and things like that. But with Stuxnet, as an example, it is quite a strange one due to it's not being internet connected at all. It was USB sticks that were dropped around the work site, and someone picked it up and plugged it into a computer.
Welcome everyone to the new Mpirical Nuclear Cybersecurity Podcast.
Interesting stuff.
Yeah, it is interesting. Maybe we could do a next podcast around that.
That's a bit too much pressure on me.
Right, on to the next question then. What is the main difference between voice over new radio compared to voice over LTE?
I'll do this one. It sounds quite obvious, really. One of them is carrying voice over new radio.
I didn't ask the question, Gav.
One of them is, so one's voice over 5G and one is voice over 4G. And it sounds like an obvious answer, but it's quite an interesting area because if you look at the progression of VoLTE in 4G, we've got nearly 800 4G networks. Most of them are mobile networks. But if you look at the proportion of those that are using VoLTE, it's only probably about 30%, which is, we assume that, they're just using circuit switch fallback to provide voice services. The challenge with VoLTE is you've got to deploy an IMS, an IP multimedia subsystem, which is your call control network, and it is a challenge. Not only that, you need to support voice on the radio infrastructure, which again is challenging because when voice gets delivered as part of a VoLTE call, it gets delivered as a guaranteed bitrate bearer. And although the bitrate is relatively small, we might be talking 25 kilobits per second, it's still a guaranteed service and there could be multiple calls taking place. So when we move to 5G, if you're a VoLTE operator already and you move to 5G, what's the difference going to be? Well, because you've already deployed an IMS, IP multimedia subsystems are access network agnostic. So yes, it will have been delivered, that IMS will have been used to deliver voice over 4G, but that same IMS can now be used to deliver voice over 5G. Obviously, the difference is in the access network, and in 5G, the whole way in which that we set up resources to carry the signaling and the voice is going to be different. And of course, 5G is a higher capacity network, so it might mean that we're able to use better quality codecs to provide higher definition voice services when you're on 5G. So it's not just a technical thing. You might get a difference in user experience between VoLTE and VoNR, but of course, you need to be very confident about your 5G network's radio coverage before you start deploying voice services on it. So Kev said earlier on, there's only about 50 standalone 5G networks that are out there presently, and not all of them will be running VoNR at this time. So it's actually quite early days, and when you go into the detail, there's the obvious major difference in the access network, but there's some other bits and pieces as well. For example, the 5G core network is very much API driven, and what we're seeing is we're starting to see in the IMS API usage. Interaction with the HSS, for example, in the IMS core can now be based on API usage. So we're starting to see changes in the IMS that kind of reflect some changes that have been seen in 5G. So I think you got the long answer there. But yeah, that's the kind of difference between them both.
Any contributions to that?
Yeah, so I mean, in terms of clarity, going back to the question, what would you say, other than the access network, what is the significant difference between VoNR and VoLTE?
It really is just
the
access network, because the IMS can be exactly the same. Just bear in mind that some operators may have been running an IMS for some time, so they might take it as an opportunity to cloud-base their IMS. Yeah.
I have a question, but I don't know if it's going to be stupid.
Go on then.
It's to do with how networks utilize and configure VoNR services and VoLTE systems potentially too, I'm not sure, as we continue to evolve over-the-top services like WhatsApp.
This is a very good question. It's quite a contentious question. Yeah, because it's difficult to bill for these services because of the proliferation of over-the-top providers. So, for example, there was a technology called ViLTE, Video over LTE, GSMA IR94, and it didn't see a lot of success because operators couldn't deploy the technology and realistically charge for the service, because things like WhatsApp and FaceTime were already offering video services free of charge, video calling services. So it's always that contentious area. The one major difference is that if I conduct a VoLTE or a VoNA call right now, my voice will be given a best effort. It would be given a specific guaranteed bitrate service, not best effort. The best effort part comes from if I'm using an OTT call provider. So if I'm using WhatsApp, FaceTime, or whatever, the network will just give me a best effort level of quality of service. There's nothing guaranteed, whereas VoLTE VoNA is a guaranteed service experience.
Okay. Are they putting measures in place to regulate quality of service for these over-the-top services?
No, because you run into all kinds of net neutrality issues which are raging at this present time. I think we mentioned it on the last podcast, and since then they've reintroduced the net neutrality rules in America.
Thank you, Gavin. And I think this one is the final question. I feel like we need a drum roll here, but if I beat on the desk here, Stuart, who's recording, will go a bit angry. So we don't want to do that. Is the security in 5G the same as AKA in 4G?
Security's mentioned, so I'll answer that.
Default.
I think this is a hard question to answer just using this format. I feel like drawing it would be a lot more useful. And I think this is within our 5G security course, the diagram for this.
Yeah.
Code Tom at checkout. So basically, the 5G AKA, the authentication and key agreement, is based upon 4G AKA. But there are some improvements surrounding fraud prevention and roaming. And the main improvements there are that essentially when we're visiting another network, we're not our home network, at a visited network, we're not passing some of those sensitive security credentials. We're passing it in other ways. So we're not giving that to the visited network, which is causing that is reducing that fraud prevention and improving roaming for users.
Yeah, it's not an easy one to answer through the medium of podcast.
Okay.
Paint us a picture with words.
Morgan, do you have any of your own questions? Because we like these.
Do we?
Anything from your side? Just before we wrap up, because it is nearly time.
No, I don't have any questions. I did come across an article from Telecom Paper just yesterday. I don't actually know what you'll be able to contribute to it, but I just saw Taylor Swift's name on there, so I think at this point all of our very technical listeners might switch off.
Well, at Mpirical, we are all Swifties.
Yeah. You Swifties. So what the article says is her fans in Portugal, they generate a massive 8.6 terabytes of data traffic over the Vodafone Portugal network during her 2-day concert. And apparently it breaks the record for the most data used on the network in a single day, twice in a row from Vodafone. So I don't really have any questions from that. I thought it was just that interesting.
It is interesting, but it's quite a pertinent topic at this time, because there's a lot of interest in high capacity venues and the way that small cells and distributed antenna systems are being used, and indeed elements of Open RAN as well.
Leave it to you to create a really boring answer.
No.
A really cool headline about Taylor Swift. But yes, continue.
Well, that was my only observation. Yeah.
Any other observation?
Well, I guess the question is, does Taylor Swift contribute to the kind of operating expenses for these networks?
Yes, that's another one. And Tom, question for you: what's your favourite Taylor Swift track? Okay,
It's got to be 22.
At least you actually know one.
Yeah.
I think we've come to a natural end point. Thanks for listening.
And the podcaster of just everything.
Thanks for listening, everyone.
Thank
We'll
you.
catch you in
See you
podcast
next
number
time.
4.
Bye.
Bye.